Okay, geometry, we've got chapter 9, section 3. We're looking at similar triangles. A couple of different ways we're going to look at those. Let's just pull up a triangle here. I'll kind of go a little bit slower so you can go ahead and copy that as I'm talking. So what I'm going to do is I'm going to actually create two triangles here, and we're just looking at being able to identify which triangle is similar to which triangle. And so let's go with, let's see, I want that to be our 90-degree angle right there. Obviously both of those are 90-degree angles, but I'll just put it on one. And so let's label some letters here. This is going to be A. We'll call the large triangle ABC, and then we'll call this point D. And so I have two triangles here. I have ABC and I have ADC. And so just by what we know for triangles, we know that order is important when I'm stating similarity. And so we have to consider in this particular triangle, finding out which angles are similar to which angles. Obviously, angle D and angle C are congruent. Okay. They both share angle A. Okay, so I'm going to go ahead and take the small triangle, and because I like to alphabetize, I'm going to call it triangle ACD. And if we're going to make a similarity statement, I go back to the information that I just put up above. I know that A is congruent to A, so that has to be the order of that. And I know that C is congruent to D. Okay, I have to be careful here. Let's see. I may have made a mistake. Let me take a look at this. A, C, D. Okay. So I need to do this. I need to label. Let me backtrack just a little bit. I have these two triangles. I have triangle ACD, and I have triangle ABC. However, in my smaller triangle, I don't actually have an angle C. And so that's what's causing me to pause here real quick. What I do know is they both have an A, so I'm correct here. Order-wise, A is going to be the same as A here. In my smaller triangle, which is this one, the one on the left, C is not a right angle. So in my big triangle, B is not my right angle. So my second one is going to have to be B. And then angle D in the small triangle is the right angle, and angle C in the large triangle is the right angle. Okay, there it is. So again, I was just struggling with the fact that I think I kind of made the assumption that angle C was a right angle in both triangles, and that wasn't correct. It was only a right angle in the big triangle. Okay, so that's our similarity statement, and I'll kind of write that without color now. So that's triangle ACD is similar to triangle ABC. Whoop, where'd my B go there? There it is. Okay, so let's move on to what's called geometric mean. And when you look in the textbook, that's on page 434, we're looking at questions number 11 through 18. If I use geometric mean, let's go ahead and take a look at number 11, and it's 8. The numbers are 8 and 32. What we do is we set up a ratio that compares these two, and we do it just like this. We do it 8 over an unknown. We set up a ratio, and then an unknown over 32. So basically what I'm looking for is I'm looking for my two numbers to cross multiply and my x's to multiply. And so x times x gives me x squared. And then 32 times 8, let me get my calculator on here real quick. 32 times 8 gives me 256. And then to find the geometric mean, I'm going to take the square root of both of those. And the square root of 256 is going to be 16. Now remember, way back in Algebra 1, where actually the square root of 256 is plus or minus 16. However, we're using these as sides on triangles, so they have to be the plus value. So we will not put the actual minus value on there. Okay, so that's finding geometric mean. And now I'm going to do one final example on giving two similar triangles and finding some missing sides. So I'm going to pause this, and then I'm going to find a good example for us. Okay, well, I draw quick, so I think I found one. I kind of like number 6. This is actually out of the textbook and part of your assignment, so this is kind of a freebie here. So there are multiple methods. The method I'm going to choose is the one we did on the first screen, and that was finding out the two similar triangles and then just creating a ratio, because that's what we've been doing. And so I see these triangles. The small triangle is QST, and the large triangle is QRS. So we need to find the similarities. Well, obviously they both share angle Q. So I've got triangle, the first one, this is going to be the small triangle. And then the large. And so it has angle Q as well. And then let's go ahead and go to S in the small triangle. Okay, that's going to be the non-remaining right angle. And so that's going to be comparable to R. And then we're going to go to the right angle in the small triangle, which is T, and the right angle in the large triangle, which is the big S. And so what this tells us is that we can create a proportion of QS over ST, and that's going to equal QR over RS, and that's going to allow us to find ST, which is what they want us to do. And so QS in this case is 12. ST, that is our X. QR is the total of that big hypotenuse, which is 20. And then we go to RS, which is 16. And so just a little bit of calculator work to do. 20 times X, that gives me 20X. Scroll down a little bit here. And then I have 12 times 16, which gives me a total of 192. Divide both sides by 20. And that's going to give me an exact value of 9.6, or 9 6/10, excuse me, set properly. So we're going to create similar triangles, or actually in this case, we're going to make them congruent and use that to find the value of x. Now, that's about 11 minutes. I think that should do it. That is Chapter 9, Section 3, Similar Right Triangles. Or in the case that we did at the end. Well, no, I guess they wouldn't, because we don't know the exact angle sides. We're just setting up side proportions. So it is similar right triangles. So rewind and kind of erase that I said that they were congruent, because we don't have that information. Okay, so now officially done. 9-3, similar right triangles.